Alright guys, we are going to start solving multi-step equations, so section 2-3. We're going to have steps just like we did with two-step equations. We're just going to add more to that. We are going to continue to use inverse operations. We have to use inverse operations when we're solving for a variable. Alright, so our steps to solve multi-step equations. First thing we're going to do is to distribute to eliminate parentheses. Now, not every problem is going to have parentheses. However, if it does, that's going to be the first thing that you do. The second step, you're going to combine like terms. Third step, we're going to add or subtract whatever is necessary. And finally, multiply and divide. So let's just start right away with some examples. And our first example is 8x plus 5 minus 6x equals 25. Okay, so looking at my steps, step number 1, distribute. Well, if I'm looking at this example, there are no parentheses. So that step I do not have to complete. So step number 2, combine like terms. Well, if I look on the left-hand side of the equation, I have 8x and negative 6x. I can combine those to a 2x. So underneath that first line, I'm going to write 2x plus 5 equals 25. Okay? Double check, make sure that if there's more than one set of like terms, you need to combine all possible before you move on to add or subtract. Okay? So now we need to subtract 5 from both sides. When we do so, we have 2x equals 20. And then finally, we're ready to divide. So if we divide by 2, we get that x equals 10. This next example that I have, notice it does have parentheses. So 12 times the quantity of 3 minus x equals 60. So again, step number 1 was to distribute. So we need to distribute the 12 to everything inside those parentheses. So we have 36 minus 12x equals 60. Step number 2, combine like terms. Well, if I look on that left-hand side of the equation, there are no like terms to combine. So there's nothing for me to do for step number 2. Step number 3 is to add or subtract. I want to work with that 36 first. And quick reminder, always look before the term to know if it's a positive or negative. So if I look in front of that 36, there's nothing there, so it's positive. The opposite then would be to subtract 36 from both sides. Please don't get confused with that subtraction sign behind the 36. Bringing everything down, I have a negative 12x equals 24. I'm ready for my last step, which is to divide both sides by a negative 12. Okay. Again, as a reminder, if you have a negative number times a variable, you want to divide by that negative number. Because now, over here on this left-hand side, right over here, there we go, over here, those are same signs when I'm dividing, which gives me that positive x, and we need to have a positive variable. So now we have x equals negative 2. The third example that I have for you, you're going to be dealing with some fractions, so I just want to make sure we're comfortable with this. So 3x over 4 minus x over 8 equals 5. Okay. Well, we don't have parentheses that we need to distribute, but combining like terms, notice I have 2 x's. So there's something that I do need to do for this step. Okay, so for our like terms, we are going to find a common denominator. So looking at 4 and 8, that common denominator would be 8. And we're going to treat this just like if you were adding or subtracting fractions. Change the denominators and then change the numerators. Okay, so common denominator is 8. On the right-hand side, on the side opposite of the equation, on the other side of the equal sign, I don't have to change that to a fraction. I can just leave that as 5 for now. So my first 3x over 4, I noticed I had to take 4 times 2 to equal 8. so I need to multiply the numerator times 2, and that'll give me a 6x. The second fraction, notice the denominator was already 8, so there's nothing for me to change, so that'll stay the same, that x in the numerator. Okay. So now, just as if you were adding or subtracting fractions, we're going to subtract the numerators. 6x minus x equals 5x. And then I'm going to replace that in. So 5x over 8 equals 5. Kind of a reminder, this is one couple different ways you can solve it. I've noticed some of you just like to eliminate the fraction, and that's fine. You can multiply both sides by 8 if you'd like, and then divide by 5. That option is certainly there. Or you can multiply by the reciprocal. And it looks like I chose to eliminate the fraction first, so I times both sides by 8. And then 5x equals 40. And now I can divide both sides by 5 to get x equals 8. Okay. If you feel maybe this fraction example you're not exactly comfortable with it, make a note, and then in class we'll go over another one of these if necessary. Okay. The last example I have for you is decimals. We haven't used a lot of decimals when solving equations, but they do happen, so I wanted to include one as an example. Looking at this one, this is just a two-step equation. This isn't a multi-step. But they're going to be thrown in there just as well, so we need to, I'm going to still go through the rules just as if it was a multi-step. So 1, do I have parentheses? Do I need to distribute? No, I do not. Step 2, are there any like terms to combine? There are no like terms, so then I can jump down to add or subtract. So looking in front of the 2.3, there is nothing there. That means it's positive. The opposite would be to subtract 2.3 from both sides. When I do so, I have negative 0.05x equals 2.50. Then the final step would be to divide both sides by a negative 0.05. And when I do that, setting up my long division, reminder, numerator always goes inside my division, denominator goes on the outside. I get that x equals a negative 50. Okay. Hopefully I provided some decent examples that you were able to understand how to solve multi-step equations. We will be spending 2 days on this. However, this is the only lecture that you will be watching for section 2-3.